There we go. I'm muted. I always mute myself so that way I don't have a microphone just listening to me. It's like, what's going on? How's everyone doing today? I can just hit one button and mute button over there. I got other mute buttons too. Mute. So how's everyone doing? We got one person watching at least. How's everyone doing? It's time to ask questions if you have them. Let's see. It's like once I end the stream, I just go over here and I mute. And then sometimes I forget. So I'm getting everything right. I'm like, oh, I didn't, because this is a new thing this semester. I'm like, I should mute the microphone. So I'm not just like, I don't know. It's kind of weird, this world we live in. You think about all the phones. I have a question about number 5 on the take-home test. Yeah, sure. Let me take a look at that. Number 5 says it should be some version of, I can speak in generalities about this, fit a simple linear model. Let's see right here. Let us predict price, a relative measure of how satisfied people are with the price at a store, from promotion, a relative measure of how satisfied people are with the promotions at a store, in the data one using transformed variables. Fit a simple linear regression model predicting price from promotion, then determine the best fitting set of transformations, copy paste into the Google form the power to which we should raise y. So, and says, if log transform is suggested, enter 0. And what is your question? You can ask in generalities. I can't go into too specific on it, but I can kind of answer general questions, not specific. I can't be like, you did this right. But it's using the find transformation function. So it's using the find transformation function. Let me head over to here. Let's bring up a screen. Do I have any linear models created? So we need a linear model. I think I've got a data frame with random x's and y's. So that's only that. Did I not create a data frame with... Create so many graphics. Feel free to ask your question. Data, 1,000 observations. Did I create that? I think I did create that. What is the name of these variables? Oh, that's the flip data set. There you go. Well, darn. Do you have more questions? Ask more questions. I'll be so bummed if that's the only question. I'll be like, oh, I didn't mean to answer it that quickly. I'm sorry. I mean, like, I'm glad you have the answer now. But we need to just make a model, and well, I don't want to say too much, but I think you get it. I think it says, doesn't it say? Don't worry, like it's like one of those moments. Yeah, it's. I mean, I don't want to write but it's using find transformations, and you have to fit the model first. So the steps for using find transformation are fitting the model, and then finding the transformations. And then I think you're getting it now. And so you're like, oh yeah, that function. We don't use it a whole ton, but yeah. Let's see, what questions are there? I might start doing some chapter 12. Might do that, but feel free to ask questions. This is, if you jump in at any time and you have questions, you can always just be like, I've got this question, Brian. I'll be like, let's do it. Especially right now where I'm kind of like thinking up questions to do. Or I'm like, I need to find questions to do. This is when, if you have a question, it's the best time to ask. Been studying a lot for the exam tomorrow, watching the replays of class. Awesome. Yeah, just hop around to be like, do I know this topic? I hope that helps. That's why I put all the timestamps in there, as you can tell. So you can, click on, you can be like, oh, let me review what RMSE is. Let me review what this is. And I try to, it's interesting. I wish everyone had access to all the different classes, but I try to teach the material in slightly different ways each time I teach it. Like, not completely different, but I try to do a little, just a different kind of way of teaching it each time I go through the material. So hopefully people get a slightly, I don't know. I figure maybe someone watches both classes or something somehow, and then what if I change it up just a little bit here? Mubot. Oh, yeah, Mubot, I guess you're talking then. You're here, Mubot. Let's give some points out. Mubot, are you awake? Am I awake? Are any of us awake? Is this real life? That's old school stuff. Mubot, are you going to give those points? Mubot gave points. Let's go right here. Let's do some of the harder questions. Chapter 12 is definitely one that gets people stuck. So, yeah. Let's take a look at some chapter 12. Hey, what's up, Jensen? Good to see you here. I hope you had some fun last night. They've got their test coming up, but Jensen, what are you working on? Feel free to be like, explain this. You can just ask me to go over a topic if you want. You can be like, go over this topic, explain this topic, go into more detail on the multiplication rule, the addition rule, or sampling methods, or anything you want. So this one's not so bad, because what you need to think about for this problem right here, I'm just pulling up a problem to do. This problem deals with like the colors on a wheel. So if you're dealing with the colors on a wheel, you have to think about how the wheel exists. Awesome. Thank you, Jensen. I'm glad you had fun last night. It was great. They did really well. If you look at wheel E can exist. Red, yellow, green, blue. You have to envision what this wheel would look like. Red, yellow, green, blue. Now it's going to be 25% red, 25% yellow, 25% green, 25% blue. So there we go. Red, yellow, green, blue. Do I have all those colors? So here's the green. This is what this wheel would look like. Green, yellow, red, and blue. So when you think about the way the wheel looks, it's going to be 25, 25, 25. Hey, Lucy, good to see you here. Feel free to ask any questions. I'm just doing a quick problem right here. This has all the probabilities are contained between 0 and 1, and the sum of probabilities is 1. This is rule number 1 of probability and rule number 2 of probability. Rule number 1 of probability is all probabilities are between 0 and 1, which this meets, and rule number 2 is all the probabilities sum up to 1. This is a possible wheel. It is possible. This wheel right here, D, is simply a real wheel that is what? It's 100% red. So when you think about the way that wheel looks, I can't speak this morning, that wheel is going to be 100% red. And it just looks like this. It's 100% red. We just spin it and we always get red. So that wheel is always going to be red and it meets all these. So that wheel is possible. This wheel right here is 40% red, 30% yellow, 10% green, that's 80%, and 20% blue. That is possible. And all the probabilities are between 0 and 1 and add up to 1. This wheel right here is 40%, 40%, 110%. Oh, but good, look. This will even it out because it's negative. That's not possible. Right here we see that some of the probabilities, at least one of the probabilities is not between 0 and 1. It does sum up to 1, but at least one of the probabilities is not between 0 and 1. That should do it for that one. This one right here is not summing up to 1. That's 80%, that's 90%, that's 120%. That one is not possible. And some of the probabilities is greater than 1. Hey, Brian, I am having a hard time with the PTA question. Yeah, let's do that one. You got it. Yeah, I got this one. Let's hop over to the PTA question. You got it, Sarah. So there's that question. And now we're going to do the PTA one. Let's do it. If you have a version of it that says something different, feel free to tell me. The PTA one, I do like the PTA one a lot. I think the PTA one's really good. It has a few tricky parts to it, but overall, I think the PTA question is a very good question to practice. So it's really, really good. Some of them, you're welcome, Jensen. That's just a good review of probability rules. The 5 probability rules are, so just very quick review here. I'll show the wheel on the screen so I remember where to put the cut in the video. It helps me out. So the 5 probability rules are: probability rule 1, probabilities are between 0 and 1. You can't have probabilities that are negative. You can't have probabilities that are more than 1. Probability rule 2, the sum of all probabilities adds up to 1. So that's to say, when we add up every single probability, we would get a probability of 1, the sum of all the probabilities. Probability rule 1, probability rule 2. If you add up the probabilities of 6-sided dice, or there's either a rainbow today or not a rainbow today. Oh, Jensen, no. The complement rule, we have either you go to Taco Bell or you do not go to Taco Bell. That's what we talk about in our class. If you're doing the asynchronous class, you're about to see a lot of tacos, because tacos rule, everyone knows that. I finished it up last night. So here's the asynchronous. I got to show you guys this. I really want tacos. I really want soccer taco. And so just you can see right here for the asynchronous class, their whole thing just has, oh wait, this one doesn't have as many, but the whole asynchronous class, you go right here, it's just there's M&Ms, and then we get back to tacos, and there's tacos. So I just kept talking about tacos the whole time through. It's I was going to put tacos rule in there, and I didn't. Now I feel sad because I didn't put tacos rule. So with this right here, there's rule number 3. Rule number 4 is the addition rule, where we can add together 2 events if they are disjoint, which is like your parents get you a rabbit, cat, or dog, and those are the probabilities, or none, and you can't have multiple things happen. Disjoint means there is no overlap. This is a event where you get a cat and a dog, which is not disjoint. And last but not least, we have the multiplication rule. Multiplication rule says we can multiply 2 independent events. Good to see you, Nightmare. Good to see you. So we can multiply 2 independent events. So kind of, it's like a Batman thing right there. It sounds like a Batman comic Nightmare right there. So I think there's a bunch, everything's like night with Batman. So, because he's the Dark Knight and all that stuff, you know what I'm talking about. So, Alexander, you cracked me up, man. Randomly select 20 parents from an elementary school, send them a survey, and follow up with a home visit if they do not visit within a week. Does anyone know what this will be? And the last part of it is just trying to stop any sort of bias. So we're going to randomly select 20 parents from each elementary school. I knew I remember that name. I think you've done that before, so it cracks me up. So randomly select 20 parents from each elementary school. Oh, okay. And that's the big part. So they're going to make sure they acknowledge the differences. I'm saying some keywords right here. They acknowledge the differences between elementary school. If they went to the first, here's how it would be if it was convenient, Sarah. Good guess right there. Let's throw 20 points out. Keep those guesses coming. Like, I want people to give guesses. I want people to, like, maybe it's not a guess. Maybe you're like, I'm pretty sure it's this. I want you to just, like, that's awesome right there. Hey, Kayla, good to see you here. Feel free to ask any questions you have. This one right here, they're acknowledging a difference between the elementary schools. They're acknowledging a difference between the elementary schools. So let's go here to our notes. And you'll notice right here, they're going to acknowledge a difference. Where's the one? Here it is. They're going to acknowledge a difference between, exactly, Jensen, yep. They're going to acknowledge the difference between the groups, and then they're going to sample in accordance to those differences and do this right here. Kayla's going to hit the next level. Kayla, I think you'll be the first person at that level, Kayla. That's awesome. They're going to follow this up with a visit to make sure they respond, so bias would only occur if they do not follow as described. Ask the parents their views at the PTA meeting. Now, this one right here, double check. If it is ever voluntary, which it's not, you'll see voluntary response bias here. Oh, wait. Oh, no. Oh, man, this is like the hardest version of this one. Because I'm pretty certain, because I've done this one a lot, this one right here would maybe get me if I wasn't practiced up this semester on it. Oof. Please, it's going to be convenience here because this is like the easiest way. This one's really hard. It's just like convenience less voluntary. I haven't gotten a single one of these wrong this semester, I think. I've gotten a few. We've done 40, 50 of these questions. I think I've gotten 2 wrong. So Brian's got like a 96 right now on this. Because there's just a few tricky ones. We got the census one wrong. The census at location with the people coming out of the restaurant. We got that one wrong, I remember. Let me look at the answers. I'm pretty sure it's going to be this right here. Oh, no, there's Beyond Bryant here. I missed the first few questions on the Kahoot last night, except count. And I think those were from early in the semester, chapter 1. Can we review it? Yeah, let's do that next here. You got it. So this is just a convenient way of going to get it. The voluntary one is the one where they ask people, they put an ad in the newspaper, I think. I think that's one of the only voluntary ones. That one's mail a survey home to every parent and ask parents to fill it out within a week. This one should be pretty obvious. Is it A, B, C, or D? They mail a survey home to every parent. So they're mailing it home to every parent. That's the key with this one right here. But there's going to be a problem because they're going to ask the parents to return it within a week. So they're going to just be like, oh, just send it to everybody and we'll ask them to return it home. So you can see what they're attempting to do. So this one should be a more obvious one. I'd love this one as a test question. I think it's, yeah, definitely census. Yep. And then you're going to probably have non-response bias. Yep. So right here, what kind of bias? We have here non-response bias, since not all parents will respond. Yep. You can't undercover because they're sending it to everybody. Response bias would be how they word the questions and stuff. Voluntary bias, everybody gets a chance. So we don't have to worry about volunteers. List the name of all students alphabetically. Contact every 20th. This one should be, like, if you get this one, you should be like, yes. Got an easy one. Got a one that's very much towards how we talk about it. Very, very kind of easy how we talk about this one. They don't mention one thing, which we do try to make a point of, is that you pick a random starting point. And once you pick a random starting point, yes, I totally agree. Kayla, you're just crushing it. Love it. And Kayla won the Kahoot last night. So attendance pays off. Kayla, Kahoot winner. Let's just you know what we're going to do? Just winner of the Kahoot, Kayla. Everyone give Kayla some I think that's awesome. I'm really glad that, attending office hours, attending class pays off. So just give some shout outs right there in the chat if you want. What kind of sampling method is this? This is systematic. Thank you, Alexander, right there. Positivity. 20 points for the positivity in the chat. And so systematic sampling. There's going to be no bias right here. Oof. So we're going to find out. Did we get that one correct? Has Brian memorized this? I have done this one a lot. They really threw me for a loop with the randomization on this one, though. I've done this one multiple times. You can go watch videos of me doing it. But this one right here, the reason that this is convenience is because the way in which they're doing it for themselves. So convenience is going to be, you go and talk to your friends. If the PTA is like, I really want to get responses very quickly, give a quote, Alexander. Well, if you give a good quote that you want, we can throw it in a MuBot. We can get it. Just if you think of a good quote, you're like, oh, I want this so I can like use it and tag it. Just feel free to throw it out there. Who was asking about this? I hope this helps. I hope this did a version similar to what you're doing and us talking through these different ones. This was the most difficult one, choosing between voluntary and convenience. And if you ever choose voluntary, you need to choose voluntary response bias, which I was like, good. If it says voluntary here and voluntary is not here, it is wrong. So there's tricks if you do it a few times. Like if you know the tricks behind it. So I was like, oh, good. Voluntary. Well, guess what? Voluntary is not. Oh, no, they've got voluntary as a choice. So now voluntary could be an option. And that's just like if you do the quiz enough, you know that trick. But that doesn't mean it has to be voluntary response sampling. But if you do voluntary response sampling, you will have voluntary response bias. So, oh, Lucy, so much positivity. Love it. Love it. And yeah, so hopefully we'll get one more version of this, and then Lucy will do the question right there. Randomly select every 50th parent. This is stratified again. We saw this one, so that's obviously going to be a good sampling method. We know that one. Randomly select 250 parents and send home a survey followed up with a home visit. We already did that one. Mail a survey home to every student. We already did that one. Send a notice to each home and ask parents to contact them. Ooh, okay. Now this one. Now don't go down further. Just think about how this works. Who's going to be responding to you? And that's the answer to what sampling and what bias this is. Send a notice home to each home and ask parents to contact the PTA to record their opinions. That is a perfect example of this type of sampling and this type of bias. So which one is this? This is the perfect example right here. Perfect example of both this sampling and this type of bias, which it'll cause. Exactly voluntary. Because just think, who's going to respond to this? The people with the strongest opinions. So this is voluntary right here, and you're going to get voluntary bias. So once again, this does fit the pattern. Nice job, Kayla. Yeah, this is just good practice, like knowing your 201 knowledge and all this stuff. Thank you for all the 201 and 320, like engaging in this conversation, because it's just good practice to be like, okay, voluntary response bias is when people who have strong opinions are more likely to respond. So it's kind of, we talk about it as the opposite of non-response. Non-response is like when a question would be maybe controversial sometimes and people don't want to respond to it. Like you see someone holding up a sign like, let's talk politics. And you're like, but you could say then that would cause voluntary response bias because people want to talk politics. So they kind of like, if I'm talking to someone and I'd be like, yeah, they're kind of similar. But I usually think non-response is when people don't want to respond, and voluntary is when people do want to respond. Like, think about this. Everyone's kind of neutral. And if you cause something so people don't want to respond, that's causing non-response bias. If you cause something so part of those groups want to respond, you're causing a voluntary response bias. So it's like, which way are you pushing people towards? You have more people who want to talk to you, or you're pushing people towards more people not wanting to talk to you. So that is the difference. Let's look at one more version. We're going to head over to Lucy's question. So this is the last version we're looking at. See if we get some new ones. Ask parents their opinions. We did that one. Randomly select one of the grade levels. Ooh, this is a good one. Randomly select one of the grade levels and contact every parent. And this is key. I like that we finally got a version of this. Is this stratified or is this cluster? You're going to go to a grade level, and then you're going to take all the students in that grade level and talk to them. That's the key part. That last part gives it away. So don't worry if you get this wrong. Is it strata or is it cluster? So is this strata or is it cluster? It is 100% cluster. Don't worry, someone's going to write strata right now. Like, oh, delete message. This is 100% cluster, and there might be differences via how we do it. We might undercover. So probably going to be some undercoverage bias, because that grade might not be representative of all grades. If anyone's wondering, why is that cluster? Well, when you do cluster sampling, just so we can show, these are the trickier ones right here. Great job, Kayla and everybody. So items are put randomly. Oh, we're buffering. Fingers crossed right there that everything fixes. Hopefully it's just a little bloop. Probably going to be switching to OBS over the weekend. I just have to get everything switched over to it, and hopefully that helps. Or it's just sudden link, and I'm going to have to deal with it across it. Usually does a census on the cluster exactly. Right there, Alexander. Great memory on that. Whenever you see that, take a census on the cluster. So if you have a group and you're taking a census on it, that's where we have it. It was just a small one. It was a little boop. It's like when your parents are driving through and hit a little bump. So, wait. Oh, wait, there we go. Take every 25th. Last one right here. Randomly select 250 parents and send a survey to them. Follow up with a home visit. That is going to be simple random sample. So they're not talking to everybody. This is going to be a simple random satisfy. Satisfies all the conditions. And Alexander, you are right. This is simple random sample because they're taking randomly selected 250 parents, and that's not going to have any bias. Satisfies all the conditions. Stratified usually is like a specific amount from each cluster. And so wait. Alexander, you're so almost right. You're so almost right. Great answer right there. I'm going to show an image I really like, and then we're going to do Lucy's question right here. I know I keep saying Lucy. I'm sorry. I think I can show it. Oh, wait. Is it the Wikipedia picture now? Yes, because it's an awesome picture. It's on Wikipedia. This is strata in dirt. So when you think about strata in Latin, I believe, means layers, or translate to layers from Latin. But strata in Salta, Argentina. So you can see right here the different strata in dirt. And this individual, I bet I don't know if they're an archaeologist or a CRM worker. If anyone knows what CRM is, cultural resource management, but I would just imagine that. I mean, they didn't dig out this unit or whatever, but that's strata in dirt. So strata is layers. And when you think about your sampling, if you were to sample this, you'd probably have more dirt from here than you would like these little thin layers. So you want to sample in accordance to the percentages in the population. There they are. You're on YouTube now, and you're on Wikipedia, so it's probably more. Friends are probably like, ogres have layers. Yes, there you go. We would stratify sample Shrek right there. Shrek, gotta love Shrek. So I actually watched a little bit of Shrek 1 recently. Okay, so Lucy's question was, we're having Lucy's question. So let's write 320 on the screen so Brian can remember. BS320. You can always ask questions. I keep thinking about using the speedrun clock. I'd have to then take a screenshot of it. I could do that. I keep thinking of what I should do because I don't do as many speedruns. Like, I like doing speedruns, but we don't do as many of them. But I've thought about when I start streaming, I should do this. And then I could have this running in the background. You wouldn't see it. I bet I'd see it, though. I'd be like, ooh. And then what I would do is whenever I get to a point of view when I change topics, I'd just do this. I need to put here more breaks in here. So I could do it where I could have more breaks and I could then easily see the times. Maybe in the future, we'll figure it out. So let's see right here. So BAS320, Lucy's question was, I think it was on the expected counts. I missed the first two questions on the queue last night. Expected counts, side-by-side box plots. I think those were from early semester. Move to everyone. Yep. Okay. So with this, when we have side-by-side box plots, and this is a good review for 201, I guess. I mean, they might have, you never know, tools and techniques questions. A box plot is going to display what kind of data? So this is just a box plot shown two different ways. This is not side-by-side box plots. This is just a box plot shown two different ways. So a box plot will display what kind of data. You can have a horizontal box plot right there, or you can have a vertical. Thank you so much, Forrest. I appreciate that. That's awesome. So you're kind of right, Lucy. What is the main key component of a box plot? What is the main key component of a box plot? So the main key component, we're throwing some 20 points for positivity right here. The main key component, Alexander, great job. We're upping it to 50 right there. Yes. The main key component of a box plot, if we go here to box plot, is going to be, it's got mad at me, right? What'd I do? I don't know what that button does. There we go. The main key component of a box plot. Ooh, and Alexander, you're right, because it shows the IQR, right? So since it shows the IQR, these are the what's in the data. Since it's showing the IQR, this is the min, this is the Q1, this is the median, this is the Q3, this is the max. Alexander, great job like coupling your knowledge together, because if it shows the 25th and 75th percentile, this has to be what kind of data. So I just want you to remember this. And that's Alexander, I'm hopefully going to mention this to people more, because if you realize, you just be like, okay, wait, it shows the box, which is the IQR right here, the 25th to the 75th in the 5-number summary. Yep. So what must it be showing then? If it's showing the 0 percentile, so the 5-number summary is, so the way I like to think about the 5-number summary is as follows, is if you were to draw quarters in the data, I know this might seem odd that the quarters look like this, it's just that sometimes they're more spread out. The quarters in the data are going to show us where the 0 percentile is, the 25th percentile, the 50th percentile, the 75th, and the 100th percentile, which is the maximum. So since this is the 5-number summary, this has to be quantitative data, and the IQR is going to be the range of the middle 50%. Because all of these are quarters in the data, there's 25% between this. It's just how tightly packed this is. Has anyone ever had, you know what I'm talking about here with what is it? Oh, it's not Laffy Taffy. What is that thing that you get and it's like, who knows what I'm talking about? It's the, you peel it and it's like the thing where you can it's like Laffy Taffy, but it's not. And who knows what I'm talking about? I'll draw one right here. Because I think this is the perfect example, because everyone gets confused. You're like, well, why is one quarter longer than the other? What is that thing called? No, not Twizzler, not Twizzler. Twizzlers are good though. Like you get the watermelon one, it looks like this. It comes in like a nice foil package. It's all stretchy. Airhead, that's what I'm talking about. Airhead. So you ever take an Airhead and you could ball up one side? Here's the watermelon Airhead. So you could stretch out your Airhead, and then you could have it balled up in one spot and stretched out. So here's your Airhead. Your brother takes your Airhead and it's all melted. And has anyone ever seen the Airhead looks like this? So here's your Airhead. It's all melted. It looks like this, right? So if we divide your Airhead into, your parents say, we're going to take this Airhead. We got 4 kids. We're splitting this Airhead up between 4 kids. So does that make sense? We're going to split this Airhead up between 4 kids. Everyone with me on that? Well, if the Airhead is perfectly symmetric like this, it'd be really easy. You would just do something like this right here, as best as Brian can draw, and you'd have it split up. So throwback candy right here. But if your Airhead looks like this, you might have to do something like this right here. Let's see. That one's probably going to be even less. Let's go here, here, and here. Now, I want you to look at this. No, see how one's gonna... I'm trying to be nice to the kids here. I got 4 kids. Okay. So when you look at this right here, and you look at these distances, this distance, this distance, this distance, this distance are different. Does everyone agree that all these distances are different? But all of these should contain how much of the Airhead? Up here, it's pretty obvious. So we'll delete off the green inside of here. Up here, it's pretty easy to see, because it's very symmetric, that they all contain 25%. But down here, if we achieved our goal, they would all contain 25% of the Airhead. But it's just because how the data is stretched out. Does that make sense? Even though up here they're all perfectly the same length, it's because the data is all the same length. But down here, the data can be kind of stretched in directions. And it works that way when you think about how our data frames look. So when you think about a data frame, our data frame may look something like this right here. These are different numbers. So if you have a data frame that looks something like this right here, it's going to be stretched in what direction? Can anyone see what way this data set is skewed? Should be one. Yes, exactly, Coop. Yep. What way is this data set skewed right here? What way is this data set skewed? What way is that data set skewed? 0, 0, 1, 1, 1, 2, 3, 6, 8. What way is that data set skewed? That's going to be skewed to the what? Skewed to the right. Nice job, Alexander. Skewed to the right because it's pulled to the high side. So you can kind of, if you draw like this, you can kind of draw a histogram and do something like that. I mean, that's not the best drawing, but it's going to look something like that, which means the center of this is going to be somewhere down here. It's going to look, I don't even know if it's going to be a weird one. It's not going to look quite like this, but it's going to look something like that. I think the box is going to be very odd. In truth, I think it's going to look something like that's, mark my words, it's going to look like this with like 0 and 1 down there. So it's going to look something like this. I think because, yeah, 0 is the minimum and 0 is probably going to be the 25th percentile. Median, yeah, it's probably going to look last attempt at drawing before we actually draw it. Something like that. And then this will go up to 3. And then that's going to be 6. And that's going to be 8. That's my last attempt to draw it right there. Let's see how it looks. If we go here to data, and we go 0, 0, 1, wait, 1, 1, 1, 2, 3, 6, 8. I have a 2 in there. I want to make sure I do it right. Yep, okay. I'll go horizontal. Oh, it does have a... There we go. So that's how it looks. Oh, it looks like my first one? Really? Oh my gosh, I should have just stopped. It looks just like my first one. I should have just been like, yes, it'll look like this. Look at even where I put this. I put that on top of it. I put the median right there. I thought the median's about 1, 2, 3, 4, 5, 6, 7, 8, 9. That makes the 5th number the median. So the median is 1. The first quartile is also 1. The minimum is 0. And it looks like the, so this is the 75th percentile is 3. And you can see that right here. So that's the 75th percentile. So if you put your marks on this, we put a mark here, 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 and here. And so that's how it works. I know I should have trusted the gut. We got to put the quote up there. Trust the gut. I should have went with it. My first answer was 100% right. I shouldn't overthink these things. I guess I could have actually drawn all the data, but my first drawing right there, I'm really shocked at how very near, this is the drawing I drew first off, and there's the actual drawing of it. I'm actually shocked. So, we gotta hit it. So, hopefully this makes sense that there's still an equal amount of data. If you look at the amount of data between these, you can see there's an equal amount of data, but the way this looks, it's all stretched out. So, good stuff right there. So you might be saying, wait a minute, Brian, last night, that wasn't the answer. Last night, the question was if we have side-by-side box plots. And side-by-side box plots look the following way. Now, I want us to look at this. Here is test A and test B. Here's the grades on the tests. What test would you rather take? And we can see this is a quantitative Y with a categorical X. Which test would you rather take right now? I'll give you the option right now. You can take version A or version B of the test. Which test would you rather take? Which test would you rather take? Version A or version B? Which test would you rather take? And this is side-by-side box plots have a categorical variable splitting the quantitative Y apart. So side-by-side box plots are a quantitative Y and a categorical X. They seem similar. These differences between these are probably due to... So the differences between these, Alexander's like, I'll take B. Alexander, you knew something they didn't know. Brian wasn't telling you the truth. Like, what? This is how the distribution actually looks. So that's the worst box plot I've ever drawn. I've drawn a lot of box plots. In this instance, did Alexander make the right choice? In this instance, yep, the F statistic. In the previous example, you are correct, Lucy. In this example, and we'll put that down below here to kind of help out. In this example, the F statistic would be high, and this would mean the p-value would be low here, which is the answer to the whole thing. Definitely B. So if the F statistic and the p-value are inversely related, the larger the F statistic is the observed variation over the expected variation that we are seeing, like the amount of variation we are observing being explained versus what we would expect by random chance. I lied again. And just there we go. Sometimes they do the width of this as the amount of people in each distribution. I've seen that they'll do the width of the box plot. So they'll make it like really small if there's only a few observations in it, which I guess is nice. But we can just like play around with this and be like, You could have weird things like this, though. Things like this can occur where you have which test would you rather take now, and what would the F statistic be? This is a more difficult test question, and I'd prefer this as an essay question. Like, it's almost like, what are your thoughts on this, and which test would you rather take? Because the answer here, there's so many ways to answer this. There's just something to communicate here. So the answer to the first one was we had them the same, and the F statistic then would be low, the p-value would be high, the differences are by random chance. The second time we moved it up, and it appears to be a large difference, which means the F statistic would be high, and they're inversely related to p-values, so there's going to be a statistically significant difference. In this one, the F statistic is what? The F statistic here is actually going to be low. The F statistic is going to be low, and the p-value is going to be high. So, Alexander, you are correct. This is the spread. So maybe your parents say as long as you get above a C, like if you get a C plus. So yeah, Kayla wants a more consistent grade. So maybe it depends on where you're at in the semester. Do you need to make like a 90 to get the grade you want? Or, are you doing well enough that you just need a consistent grade? So it depends. Like maybe you're like, I really need a 90. So then you would want distribution A, because distribution A is the only one that has the potential to get a 90. And this is, let's just say this is like historic data, which we know like it's very unlikely you'd fall outside these ranges. So distribution A would have the potential for a 90, but also the potential for a 70, where distribution B has the potential for pretty much like, 82 to 78. The width in the bar chart. So there sometimes they do a width down here. It's not always common that they do the they'll sometimes show the it's interesting. Some graphics do that. I like consistency. Yeah, if you like consistency, then you'd go with B. There's less variation. And you might say, well, Brian, you're saying everything here is due to random chance. Yes, the differences between the means or medians, depending on which one we're calculating here, those differences between the means or medians are likely due to random chance, but there does appear to be a difference between the variation. And I never do that test. There is a test to see if there's a difference between there is a test to see if there's a difference between the standard deviations, and I don't know. I don't do that test. It's just test the standard deviation. I don't do it. The other question was on the chi-squared, table, which we will do in 201. So let's talk about it. So Alexander, this is really good talk right here on 201/320. So 201/320. I think people maybe skip those parts of the video because they're like, "Oh, this is like advanced 201." But we will do this. So we're talking here about the chi-squared test. The chi-squared test is when we have what kind of data? Let's say we have class A and class B. And let's look at people who make above 90, and below 90. So like you make 90 or above or below a 90. So we look right here, class A has 20 people. And class A has 30 people here. And we look here and 18 and 32. So taking a look at this data right here, and we'll do the outside portion. Oh, good. This is turning out decently nice. 38 and 62. Okay. Mosaic chart, exactly. So mosaic plot. I guess you call it mosaic chart. I don't call it that, but mosaic plot, exactly, mosaic plot. So what kind of data are we dealing with when we're dealing with the chi-squared test of independence? We don't call it that in this class. It's just testing the discrepancy. Contingency table, yep. And so you actually, Kayla, you're totally right. This is a contingency table. We could then build a mosaic plot from it. And if you think about this, class A and class B each have 50 people in it. So what we'd notice down here when we build the mosaic plot, and actually this is really easy to enter into jump. Sometimes it's easier to enter things into R, sometimes it's easier to do jump. So this will be bivariate what? Be very careful, because you're saying, are you in class A or are you in class B? Are you in class A or are you in class B? And you're saying, did you get above a 90 or below a 90? So this might be trickier here because that looks like a grade. I mean, it is a grade, but you're saying, did you get above this or below this? It's categorical. So And great job, everybody. Excellent work. So we'd go right here. The below is going to be this. And this one has a little bit more below. It's going to look something like this right here. Let's view it in jump and take a look. So it's just, I can enter it into R, but it's not, I've never found a really good way to quick type these in. Because I first learned how to do this one in jump. So let's go class and then we want above, below, and, oh, no. And then we want to put in the frequency. There we go. Put it over here so we can see it. Okay, class A above, that's 20 people. Class B A below, that's 30 people. Class B above, that's 18 people. Class B below, that's 32. So we've done it right there. And analyze. There might be, I'm actually working on some stuff. So each variable has two levels. Yep, it's two-level categorical variables. And so we can see right here, we go to fit y by x. We can see if somebody's class explains their grade. Let's see how good Brian's drawing is. My quick little drawing. Oh, it flipped it. We're going to show jump. Take this mosaic plot right here and flip it to, do that to mosaic plot. So there we go. Let me go over here and do the, there we go. So that's what I thought it would look like. A and B are on the other sides now. I'm making this happen. It's gonna look like mine. There we go. Look at that. I'll take it. Close enough. What do you guys think? How does Brian's drawing compare here with A and B? So there's class A and there's class B. I'd say we did pretty well. Trying to get about, should have been 60%, and that's going to be 64%. So hopefully Butamus, it just changed the way it was showing the up right here with all this, right? Flare it. We will make it happen. We will make our drawing look like theirs, the way they configured their percentages. So I'd say it looks pretty good. Looks pretty good. So when you look at this output, the way Jump wants to display it, we've got the people who made above in class B, and you can see the percentages, which is 36 versus 64 right here. We got the people who made, now what are these right here? What are those? Brian is highlighting a what distribution right now? Brian is highlighting a what distribution. This right here is a what distribution. This, within this right here is like for only people who are in class B or given people are in class B. That is a what distribution. That is a what distribution. Given someone is in class B, that's the best way. So it would be conditional because you're setting a condition. Marginal, when you do marginal, the best way to do marginal is to not mention the other variable. So ask me for a marginal distribution. Say, Brian, can you talk about the marginal distribution of this? Like, just ask me, like, Brian, can you talk about the marginal distribution of this? Like, just phrase me a question and see if you can get me to talk about a marginal distribution. Like, or you can say, Brian, what this? Like, ask me a question that would lead me to talk about the marginal distribution of this. So think of a way to ask a question right now that would have me talking about the marginal distribution, that you can say, hey, Brian, can you talk about this? Or can you tell me about this? How would you phrase something? And everybody, thank you so much for all the positivity. I'm going to throw some 20 points. Can you talk about the marginal? Well, phrase it towards this. Exactly, Alexander. What is the marginal distribution of class? So the marginal distribution of class is 50% of people are in class A and 50% of people are in class B. Does everyone see that? 50% of people, and that's because this looks so even right here. But then if you say, Brian, what is the marginal distribution of people being above and below a 90? I could say, for all students, 38% of them were above a 90 and 62% of them were below a 90. This is the marginal distribution here. And I want you to just put in the chat, where is the marginal distribution? The marginal distribution is always where? Where is the marginal distribution? The marginal distribution is always where? Where is the marginal? It's in the margins. Exactly. No, once you say that, you're like, oh, it's in the margins. So here's the margin right here. Here's the margin right here. And down here on the contingency table, here's the margin right here. Here's the margin right here. They do flip it. That always confuses me. But the marginal distribution is in the margins. So good practice right there. If you set a condition, you're looking within one of these to say, for only people who are in class A. So that sets a condition. Like given someone is in class A, what is the probability they got below a 90? And it would be 60%. So good stuff right there. Yeah, the totals for just one of the variables. A marginal distribution is the same as a frequency table. So if we go back here and we just do the following, it's going to be the same as analyzed distribution. And I think this will work. Let me try this. Yeah, there we go. These are the marginal distributions right here. You can see the 50-50 split, but these are the marginal distributions right here. So the marginal distributions are, and I'm pretty quick with jump, but jump's really limited on what you can do. Like jump's good. Hey, Maddie, good to see you. Hey, Maddie, 320, right? Or wait, was it 320 or 201 last semester? Good to see you, Maddie. It's so hard with the names. I'm like, I know, because it's previous semester, right? It's so good to see you. 201, yes. Thank you so much for swinging by. We're here having some fun. We're reviewing 201 and 320 at the same time. And so we're going to go to Lucy's question right here, which is, how do we get those expected counts? So when we do this in 201, so we'll be doing this very shortly in 201. Watch this. I wish, man, I miss teaching like when we have it all printed out. So watch this. Are you ready? Here is how to get an expected count. What is the formula for expected count? Now you can put this on your cheat sheet. Sorry if I've been honest, but will there be a short answer questions on the midterm? There's not really any short. Oh, there's just the interpretation, I think. Just interpretation. Great question, Kayla. Just interpretation, really. You guys are cracking me up. Observed. So the F is the observed over the expected. Exactly. The F is the ratio of the observed variation over the expected variation. Mm-hmm. And so for this one, row total times column total over grand total. Yep. So I want you to tell me how many people in class A did you expect to be above a 90? How many people in class A did you expect to be above a 90? Try to solve this right now. Let me write it down as a problem. How many people in class A did you expect to get above a 90? How many people in class A did you expect to get above a 90? See if you can solve this one right now. How many people in class A did you expect to get above a 90? Well, that's how many people did get above a 90. This is going to be the observed. So this is the observed. And Alexander, this is really great practice for the future. So don't worry. We're going to throw 20 points out there again. I think that might be technically correct, but how many people? Let me look. Let me see here. It's close. I think you are correct, Lucy. And so show the mathematic. I think Lucy is correct. So let's see the mathematics right here. Here's how to do it. We need to connect the numbers the following way. We're going to go here with above, and we're going to shade down this way. And then we're going to go across class A right here, and we're going to shade across. Does everyone see how this intersects? And there's the two numbers we're using. So the two numbers we're going to use are this row total, this column total. We're going to multiply them together, and then we're going to do this over the grand total. You know what I'm going to do? I'm going to do that in green so we can see like these are the right ones we're using. So we're going to do row total right here, column total right here, multiply those, and do this over 100. So Lucy, I think that is correct. Yep. So you would expect 19 people, especially if you're in 201. You can always do practice by checking your numbers right here by going to the expecteds. You can also do this in 320 because it does give you these values. Here, let me put it this way. Here's a really great example. I'll do this in 201 also. Watch this, Alexander. I think you'll get this. Brian has in his class right now. Okay, let's do this. We've got 201 students. So we've got 201 students and we've got 320 students, right? So we have a huge session and there are 900 201 students in here. And there's 100 320 students. It's like everyone shows up. Everyone's here. And Brian asks a question where half the students get it right and half the students get it wrong. Okay, so like right or wrong. There we go. So I want you to think about this. I only want you to look at these numbers here. With this, I want you to look at this. Brian's got 900 students here, and the numbers make it easier on this one. These numbers make it way easier. Half of his students get the question right, half of it get it wrong. There's 900 201 students, and there's 100 320 students. I want you to tell me how many 201 students would you expect to get it right by random chance? How many 201 students would you expect to get it right by random chance? Just, we don't know how many students got it right now. Just how many would you expect by just what these numbers suggest? How many would you expect to get it right by random chance? Think half the students got it right, half the students got it wrong. You got it, Coop. And you've actually done the mathematics here. It's much easier numbers to calculate with this example because it's a 50-50 split. You're like, well, half the students get it right, half the students get it wrong. There's 900 201 students, so I'd expect 900 to get it right. Does this make sense right here? So you're actually doing row total times column total over, and the grand total here is 1,000. So you're actually doing row total times column total over grand total. It's just the numbers are so easy, and we know in our heads that, well, you know, half the students are 201, half the students are 320, so I'd expect half the students to get it right. So that just makes life way, 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 way easier. But what if, let's say most of the students get it right? Like I ask a really easier question, and 900 students get it right, and 100 students get it wrong. How many, exactly, yep. And so how many 201 students would you expect to get it right now? So how many 201 students would you expect to get it right now? How many 201 students would you expect to get it right now? And just think, you can kind of do the math in your head. You're like, well, if there's 900 201 students and 90% of the students get it right, so I'm doing it in my head right now. So how many 201 students would you expect to get it right now? And you can solve it with the actual mathematics by doing the following, and just think 9 times 9, that's going to give away the answer. 810, exactly. And so you can solve the mathematics here. You'd say, well, I'd expect, and this is not, we're not saying what will happen, we're just saying what we would expect. This is some of the ways I like to teach it and show it. And then if you remember row total times column total over grand total, that's the way to do it. What you're actually doing right here is you're actually doing the law of, this is so interesting, and this is a great place to like bring it back to. You know what rule you're actually doing, 201? So Alexander, you're actually doing the multiplication rule right here. The multiplication rule states that we can multiply two events if they are assumed to be independent. So the multiplication rule that we just covered in class, the multiplication rule is the probability of A times B. But you say, wait a minute, Brian, if I look at this, what we have right here is actually 900 times 900 over 1,000. So you'd say, Brian, this is not two things times together. It's two things times together divided by another one. Good to see you here, Cliff. So what we actually are doing, interestingly enough, is the following. Mathematically, we're actually doing this. So this seems more complicated. So, well, and they wouldn't be mutually exclusive because you can be right, and so they wouldn't be mutually exclusive. They're going to mutually exclusive. They would, I just can't speak today. They are going to be, they can be inclusive because they can both occur. But they are assumed to be independent when we do the test. They might not be independent. We might have evidence of that. So should we use this when we're asked to give this is when you're asked to give an expected count. So this is all the expected right here. Let's put that at the top of the screen. This is all talk about the expected count. When you're asked how many you would expect. So especially for math people right here, what we're doing is we're doing the law or the rule of independence to multiply things together. And then why would we times it by 1,000? When you times it by 1,000, you're not going to get the probability anymore because this is the probability of it right here. And then timesing it by 1,000 would do what? It's not going to be a probability anymore. Timesing it by 1,000 will take it out of a probability and turn it into how many. Does that make sense? Like, we went very, very mathy on this. My mind kind of just exploded when I realized this like 5-10 years ago, or like, about 6. I don't know, it was halfway. It was a few years into teaching. I was like, wait a minute, this is just the multiplication rule. And then we're turning it into the count because we're assuming independence when we do this multiplication right here. So what you're seeing down here on the bottom is the long way of doing it. acknowledging that we're multiplying two independent probabilities and then turning it into a count. So maybe that brings someone to a deeper understanding of this. Maybe everyone's just like, cool, Brian, you like this stuff a little bit too much. But the more years I teach it, the more I try to figure out stuff. We turn probability, exactly, that's what this does right here. And then so all you have to do, Lucy, thank you so much. 20 points, Lucy, right there. We're turning the probability into a count. That's all we're doing by timesing it by how many observations there are. And then if you just reduce this, you would reduce it the following way. And so you reduce it like that, and then you can just share the thing like this. So that's what's happening right there when you do that, is you're just doing the following. So you don't need all the complication. It's row total times column total over grand total. So the formula you can see up top right here is row total times column total over grand total. Row total times column total over grand total. That is how you get the expected count. That is the expected count. More questions. We got enough time here. Is there another question? We're near the end. So just like numeric values for interpretation of false sentences. Oh, wait. Oh, did I miss your follow-up? I'm so sorry. All the interpretation stuff. Sorry, Kayla, I missed that. How did I miss that? It's just going to be like, so numeric entry, interpret. The only thing you really have to type out right there. I did get on a roll. The only things you're really going to have to type out, let's throw another 20 points. The only things you're really going to have to type out are the interpretations. There's going to be like numeric entry where you have to like, solve something, numerically enter it in. Not a ton of those. The mathematics is not complicated on this test. It's the real things. I don't think there's any other, I need to double check. Like, I've looked over a few different versions of the test. Like I kept simulating versions of the test because we've got a lot of questions. We are also going to look at instructor. So here, let me talk about the 320 test. So Kayla, the answer is, I'm 99% certain that pretty much everything you're doing right now is just like when you have to write down answers are going to be in the interpretations we've covered in class, especially. If you're in today's class, we're going to do a big thing on interpretations. Try to remember who's in today's class. We did interpretations yesterday, so I'm going to do that today's class too. So, my gosh, I'm rambling. But the big thing is we had all the instructors work together on this test so that it's kind of not just Brian's test. It's also Brian's test, Dr. Lee's test, and Terry's test. I've looked over a lot of the questions, and because there's a lot of questions we've wrote. There's a lot of different ways this test can simulate, but it's probably going to give you a test. Like when you think about the law of large numbers, everyone's going to get a test that's pretty similar. We have question banks that it's drawing from, so you're not going to get all of one topic. You're going to get, just a random assortment of questions that are evenly distributed over the material we've covered. And so you might have questions that go over a little bit of one area a little bit more, a little bit of one area a little bit less, but it's going to be across everything. But we have it so I would say there's millions of tests people could get. That way, if someone we don't want you going to someone to be like, hey, there's this question on the test. Don't do that. That's not good to go to people and be like, I took the test and here's what my question 1 was. We want that if that were to happen, that wouldn't give anyone an advantage. Like if you knew someone's test, you'd basically know a practice test. You would know, and so it'd be like, oh, I can tell people because it just be, don't do that. So we want there to be enough versions of the test that, my goal in the future is that we have like 500 written questions. And so if you actually knew all 500 questions, you actually know the material. It'd be like, well, you memorized all 500 questions, so you actually know the material. And then we create a few more questions. You're like, oh, dang it, I didn't memorize these. And we have some questions that change when you take them, like the numbers will change. So we have some questions that generate the numbers. So the goal is kind of like the ACT or SAT. You couldn't tell someone your ACT questions and then they'd be like, oh, I know your answers to the ACT. It's going to help me. So if you're thinking about it, we want to create these tests here that, we can use over many years. That's been my goal, is to keep growing this. And so Dr. Lee and Terry have helped out a real big deal with this, with growing the question bank we have. So we probably have 200 questions, maybe something like that right now. And they added like another 70 or so questions. I went through and looked at them, and I didn't see any problems. There was one I was changing around last night because it had a formatting issue. But if you see any issues, please let us know. If something goes wrong with the test, please let us know. That's the biggest thing. On the review quiz, I missed the numeric entry with two decimal points. How many decimal points should we include on the midterm? Just when you look over it, if you think that you got it, but it didn't count it, just let me know. So Lucy, good question right there. The numeric entries should be a plus or minus. like they should. So entering more should be fine, and they sometimes they'll tell you how many to enter in. I like it where we put it as numeric entry. And also when you review it, just tell me if you think you got one wrong that you didn't. I actually go through and look at a lot. With 320, I take the time and usually look at as many as I can to see what people got wrong. You can always ask me to review it and say, hey, Brian, I put in 28.2 and it wanted 28.23. Pretty sure I understood this one. I'm still confused. Will we have to type out full sentences, interpretations, or only numeric values for interpretations? Full sentence interpretations. Full sentence interpretations. Let me write this in big letters right here. I'm going to make this as clear. It's a great question because I want everyone to know. Full sentence interpretations. Please do this properly. This is a huge topic we're going to talk about today. Full sentence interpretations. Please do this properly. I can see a lot of people losing a lot of points in this area, and I'm not joking. I've taught this class for 6 years now. When we do this in person, when we do this online. Exactly. And Lucy, you're in yesterday. I think Kelly, you're in today's class, and Lucy, you're in yesterday's class. So Lucy can definitely let people know we went over the interpretations step by step by step by step. Yep, and those aren't on the review quiz just because those have to be manually graded. And if I had infinite attempts on that and I had to go in and manually grade it, oh my God. Every night I'd be like, okay, I got to go. Okay, I got 20 to manually grade right now. Okay, wait, there's another 5 to manually grade. So, it'd probably help if people saw that, but like we manually graded those. But yeah, time constraints are fun. There's a button on my mouse right there. There's a third button on my mouse. I don't even know what that third button does. What the world does that button do? Didn't even know I had that button. Yeah, if I, maybe I'll have a TA do it and we could say they're graded nightly or something like that. I could see it in the future. Like there might be a way to do it. Yeah. For RMSE, our model on average misses by, here we'll do a quick RMSE one. Let's look at an RMSE. What do we have saved as a model right now? Our model right now is predicting, is it abalone still? Oh, here we go. Classic one right here. We did this on our assignments. We're predicting demand from average temp. So what is this right here? New button. And I'll probably head off here in a moment because I think I'm teaching in 30 minutes. I'm going to look at some emails and stuff. What would be the RMSE right here? I think if you're in today's class, we'll definitely do it. I'm rerunning my old assignments with random students. Ideas, directions. Yes. What would be the RMSE right here? Here we'll do, we're going to do all these interpretations. Let's do all of them. So we'll stay here till about 11:40. We'll go a little longer. Let's do it. Let's do all these interpretations. 12:40 your time. I'm back in time. What is that's not the RMSE. It is 1451. I had the R squared. I was like, wait a minute. What is this going to be interpreted as? What is this going to be interpreted as? And I appreciate everyone saying, on average, our model misses by... Yes, yep. And you could say bikes or things like that, like the demand of bikes by this. Yes, Lucy, that'd be 100%. On average, our model misses by 1451 bikes when predicting the demand for bike we need. You could say, when we make predictions with our model, we usually miss by about 1451 bikes when predicting the demand. So, yep, and Lucy, your answer would get full points right there. That is correct. You don't want to use words like will. Will is going to lose points right there. You don't want to do that. How about the R squared, which is this one? How about the R squared right here? What is the R squared going to be? So I'm going to let everyone, I want you to pause the video here, especially if you're going along. I want you to see how close you are. Great job right there, Cliss. On average, our model misses by 1451 bikes when predicting the demand. Yep. And it's always like in units of the Y, because this is how much we miss our Y prediction by. What is the R squared right here? And there's different ways to say it, but we always kind of go by our kind of formatting. Definitely watch the class because we're going to go over this more in detail and do it more slowly. We're just kind of like doing some knowledge checks right now, doing knowledge checks. Can we do it? 31.8% of the variation demand is explained by the variation in average temperature. 31.8% of the variation demand for bike rentals is explained by the variation. Yep, just throw in variation, Cliff. This would be a 2-pointer. I'd be like biting my finger and I'd be like, you'd either get 1.5 or 2 points. I'd be so close. I'd be like, because it's the variation in it, like, over the variation of the X, we explain the variation of the Y. That's more technical, but to say like, there are other ways of saying it that are fine. I'm going to do a totally different way. Like understanding the variation in average temperature gets us 31.8% of the way to understanding the variation in demand. So it's like we understand this much of the other variable due to this other one. but I like blank percent of the variation y is explained by the variation in x. So blank percent of the variation y is explained by blank percent of the variation y is explained by the variation in x. There we go. How about the intercept right here, which is actually logical? The intercept is actually logical because the average temp is in Celsius. 0 degrees Celsius is what? 0 degrees Celsius to Fahrenheit. That's just 32, right? Why am I asking that? It's 32. So when it's freezing outside, when it is actually freezing outside, that's what is. So how would this be interpreted? So how would this be interpreted? Yep. Absolute zero, not absolute zero. Is that absolute zero? Is that what it is? Yeah, the absolute zero is different. Absolute zero is like, is 0 degree Kelvin? Is that absolute zero? I think 0 degree Kelvin, right, is absolute zero. So when x, close. Coop, remember to do context. Coop, if this is a 2-point question, you might get half a point. It would be dead. All our molecules would stop. It is Kelvin? Yeah. So all of our, like, that is the point at which I think molecules stop. The average bike demand, the average demand of bike rentals among days with no average temperature is when x is 0. So not that there's no average temperature, really close right there. And that's, oh wait, I have it covered. Yeah, don't worry. That was just because it was covered and I looked weird on your screen. We expect days with an average temperature of 0 Celsius to have a demand of, yes. And then we would say really close. Hopefully I have, let me look at my Mad Libs version of this from yesterday. Make sure my Mad Libs did it properly. Where's the Mad Lib version of it? Too many things. Oof, I don't know where I put the Mad Lib version of it. Which untitled document is it? Oh, geez. Okay. I don't know where the Mad Lib version of it is. When the average temperature is 0 degrees Celsius, the average demand of bike rentals expected, yes. We expect individuals with an x of 0 to be 0. Yeah, we expect. You need the expect in there as long as you don't have will. Yeah, I think Lucy, that's correct. Like, if I consider it for more than a few moments, I'm like, yeah, because there's so many like little nuanced things you can say. I think everyone here would be getting credit. Like, we'd expect the average we'd expect bike demand. So I think Lucy, you got it. Yeah, we expect days with an average temperature of 0 degrees Celsius to have a demand of this. Yeah, we expect. Because that's what we would predict. We'd predict that. So 100%. My brain just went a little too like, I don't know, being like, let me overanalyze this. That's what I do. So let's go right here and look at the last one. What is this? We got a big one to end here last. Let me get some more coffee between class. The last one right here, definitely a tricky one to do. This is the one where I see people losing points. This is a 3-pointer on the test. I see people losing a lot of points on this one. I will grade your answer if you put it in the chat. I see people losing a lot of pointer here. This is the coefficient of the slope. I don't know what I was going to say. It's coefficient of the slope, and I see people losing a lot of points right here. This is the one where I see people, I'm just like, nope. I'm going to actually be writing up a thing for Terry and Dr. Lee so that they can grade the same way as us. So I'm writing up something for them to make sure everyone grades pretty identically. Because I don't want people to be like, Brian graded this way harder than everybody. My friend wrote the same thing and they got more points. I'd be like, well, I told you I was going to grade it hard. And so I'm going to hopefully have everyone on the same track with the grading. So that way because there is some subjectivity to this, but I want it to be as close as possible. I want everyone to do about the same, which is, you can't have exactly the same. There's going to be variation in grading, but we can try to standardize it and reduce the variation. That's what statistics tries to do. So what do? You make operational definitions. But I mean, there's about a billion ways to answer this, or infinite ways, technically. Snare, you're close. There's this, out of 3 points. Let me see here. And I want you to, what we always do, I think Lucy got it. So I want you to always read what you write and then be like, does that make sense if I say it to someone? And I'm throwing some 20 points positivity out there. Actually, you know what? I'm throwing 100. This is a big one to go out there on a limb on and do. And I really appreciate it, especially being first right there, because you don't get to see any answers to check your own and be like, does mine look like that one? So thank you very much. What we want to hear is we want to talk about 2 days, because When we talk about the average temperature, we're talking about 2 days that differ in their average temperature by 1 degree are expected to differ in their bike demand by 138.331 bikes, where the day with the higher average temperature is expected to have a greater demand. Lucy, that's 100%. I read that and I'm like, yep, full points. Totally got it. Good. So, and then Snea, I think, let me see here, 2 temperatures at different average temperature by 1 degree with a higher temperature. So I'd probably, I'm between 2 and 1.5. Like, I might give you 2. I'd probably give you 2 out of 3 points. I'd probably give you 2 out of 3 points. So I'd probably give 2 because you're kind of right there. Does that make sense? 2 days at different average temperature by 1 degree Celsius are expected to differ in their average bike demand rental by 138.331, with the day with the higher temperature. That Coop, we're throwing 20 points out there. I'm getting a lot of points. So we're throwing a Coop. Thank you so much. If you wrote that on your own, Coop, you got it. Which is all right. If you copy paste, that's fine too. I mean, you can't for the test, but if you that answer right there, having that, yeah, exactly. That's and that's just the practice. It's, don't worry, and I want everyone to be positive about this. I just want everyone to know let me ask you this question. This is a question I want everyone to know. What does being wrong feel like? This is you're gonna be wrong on what a lot of people don't realize what being wrong feels like. What does being wrong feel like? Let's have 1 minute with that. What does being wrong feel like? This is Brian's last little thing right here. We do a last little thing. What does being wrong feel like? Does it feel uncomfy? I know, Lucy, you're like, yeah, being wrong feels uncomfy. Feels just like being right until you know you're wrong. Exactly. And you have to find out you're wrong with these things. You have to find out you're wrong. So, like, I don't say this as a joke. I know it has corny music in the background. But if you're wrong on something, it feels just like being right. You're just like, I got this. And then you find out wrong. You're like, finding out you're wrong feels bad. You learn better when you mess up. Exactly. Learn that as a student athlete. Snea, you know what? 100 points. I appreciate that right there. Like, that's exactly what we want to hear right here. We want to mess up. We want to make mistakes. Why do we fall down? So we can get back up. Like, we fall down, we get back up, and it just makes us stronger. It's like, it sings like I don't know. Sounds like every early 2000s song trying to pump you up for, But it's true. You have to make these mistakes. You have to get things wrong. Because the more mistakes you make in class, the more wrong answers you give right now, the less wrong answers you'll give on the exam. That's the goal, is to be like, I was going to put that down. Exactly. You're free. I don't know if you don't have to say what you did, but you can say, because I'm interested now, like, did you run? Did you, I don't know. I did running, so that's what I always think about. I get knocked down, but I get up again. You're never going to keep me down. I get knocked down, but I get up again. You drink some whiskey shot. That's Chumbawamba. But yeah. No, and shout outs to student athletes. You should see what they do. It's pretty crazy. Lot of respect. And I was telling my fiance that some of them, if you get knocked down 9 times, get up to 10. Yeah, exactly. Get up to later. I was saying to my fiance, some of, I played tennis at a small D1 school. Yeah, cool. Tennis is, my brother was good at tennis. He made me feel bad at tennis. And then my mom would offer us $20 if we could beat her at a set in tennis or something. We could beat her at a game. I think she'd give us 5, and she wouldn't let us win every week or something like that. I beat her at a game. I don't think I ever beat her at a set. Oh god, it'd be so mean if I was like, hey mom, I never beat you at a set of tennis. Let's go play now, because she's in her 70s. She'd probably still win. I'll be like, I will win now. And she'd be like, no, still better at tennis than you, Brian. Still better at tennis. She was good. She could play. But yeah, it's, she wanted to get us out and get some exercise. So she'd be like, yeah, if you get better at tennis than me, I'll give you $20. So, sprinter. Yeah. Tennis is probably hard on the knees, I bet, because you got to change directions a lot. Just don't hit something, you just got to go. Man, that's tough. I was I was pretty bad at like overhand serves, like throwing it up and whack. I don't know. It's pretty bad at that. I just realized something, and man, the world. I miss the world. We went out for my sister's birthday and went bowling, and I think I got 5 strikes in a row back in September of 2019 before the world changed. I know it was so hard for me. Like I was just bad at that. But I wish I tried to take a thing of it. I think I bowled. I bowled randomly something like 196. I think I was right under 200, and it drove me nuts that I didn't hit 200. But it got something like 5 strikes in a row. I'm not even joking. Like I'd never bowled that. Like I used to do bowling, not like I used to be in bowling club when I was in 6th grade, and I would get like 150, 140 like regularly. My back made me feel like an 8-year-old when I play. I bet. Everyone knows exactly how tall Brian is. Brian's 6'3". My back makes me feel old. Like my back, like I'm like, oh, but Alexander, if he's still here, he's got me beat on being tall. So knee problems were consistent. Yeah. Roger Federer, good tennis player right there. Long distance running was the thing I despised when I trained. That's all I did. I was cross country. I need to get back into it. I need to like, I don't know. I say I need to run, and then I remember. Here's why. I used to run as a 6'11" guy. I feel like I'm dying every morning. Yeah, it's like, yes. I snap, crackle, and pop Rice Krispies. Oh, man. Don't destroy your joints. Yeah, Connor, you've got some good workout advice. Connor, so real quick here before I head off, because I got 22 minutes before class. What should I do to work out? I should probably swim and bike, probably. Yeah, running's too much on my joints. No joke, I actually had, is it rheumatoid arthritis? I had it like in my hip. Probably why I have like pains nowadays. Cause probably when I did cross country, we'd sometimes hit 100 miles a week. You're like, 100 miles a week? I'm like, no joke here. We'd go out on Saturday and do long, slow distance runs. So people know long, slow distance. So you're like, we're doing long, slow distance runs. We would go out and do, on Saturday, we'd do like 20, 25 miles. Yeah, I should do some swimming. That wrecks my hair, though. I like my hair. It's very, very soft and very, yeah. So, like, no, just like MSM. You know, I've got turmeric. I actually bought some turmeric. So that'll help. I should try it. What do you put that in, Coop? There's like, I should do swimming and biking. Get a bike. Oh, man, I did have a swim cap. If you go back 9 years, you'll see Brian down at the pool, the T-Rec, putting his hair in a swim cap. Yeah, I've heard it's a natural anti-inflammatory, and remember last semester, I haven't tried it yet. What do you put it in? What do you put it in? I mean, I'm Indian, turmeric was everything. What do you put it in? Should I mix it with rice or something? What do I put it in? I have a bag of turmeric. I'll go grab it. Give me 10 seconds here. Literally, I'll be right back. Watch this. I'll be back. Don't leave. I lied, I don't have turmeric. What is this? Oh my god, it's turmeric. It smells. Everyone's saying it's so good for inflammation. Look at that screen. It's turmeric. So what do I do with this? I just like eat this turmeric powder? I don't know what I do with this. Yeah. Curry and vegetables. Yeah, I love curry. Curry's some good stuff. Coconut curries. Peanut curry, coconut curry. So many curries. There's so many. You put in your eggs in the morning. We've got some good vegetables right now. I'm trying to eat healthier. We'll listen to one more song, then we'll head off. Just don't put too much turmeric in. I put it into seasoning for chicken rubs. The best way is if you mix it with milk or water and drink it. That's my favorite. Okay, cool. We've got some oat milk, and so maybe I'll put it in. How much do you put in? Last advice for Brian right here. How much do you put it in? This is like health advice with Brian. And honey? I've got some what is it? Red Velvet protein powder. It's like health advice with Brian time. Gotta go see you, Lucy. I drink oat milk as well. The oat milk's pretty good. Oat milk's pretty good. And like, I don't know. I've been considering that I should become an ethical vegan. I love bacon. I love stock and barrel. I love burgers. I don't know. I don't know. You become convinced of things, and I don't know. This is last Brian's views. This is Brian's views. I just think about like how our society with factory farming treats animals, and I wonder if my views on this is Brian's personal views. I had bacon this weekend, like, and then I'm just like, have I been conditioned to think it's 100% okay? Like personal views with Brian. What's up, Bryce? Good to see you here. So Brian's like views, like working his internal mind, being like, why do I think the things I think, and should I think the things I think? But you can't you can't like make yourself believe something. And then, I don't know, this is the introspection I do. So I keep myself up at night being like, why do I think the things I think? Do I have free will? I don't know. My husband and I have been changing our diets as well. And as a bodybuilder, he always ate bacon. Yeah. So what's his thought on that? I think it's good to do introspection too. You have to be willing to critique yourself and be like, could I be wrong about this? So I'm not saying anyone here is wrong. I mean, I just ate bacon this weekend. They're like, you're wrong for eating bacon. I'm just like, we don't need it anymore. It can be done. Yeah, awesome. Has that helped, Coop? Like, and is your husband a bodybuilder? Like an actual actually like competes and stuff like that? I had some black bean soup a few nights ago. Really, really good. Really, really good. And I know beans are good for protein and stuff. Eating a toast sandwich, yeah, at the very moment. Yeah. And it's like, I'm not going to critique anybody, but I heard a really good this guy Cosmic Skeptic, if you know Cosmic Skeptic, great YouTuber. He gave a TEDx talk on ethical veganism, and I was like, he makes some good points. Yes, and as an actual competitor, not anymore though. That's awesome. Whoa, what's he? If you want to say? Yeah, Cosmic Skeptic. Coop knows Cosmic Skeptic right there. So he's got some good videos and stuff. Like whatever your viewpoints are on stuff, perfectly fine. But I've actually spoken to him, Coop. I've actually spoken to Cosmic Skeptic. I don't know him. I do not know him. Don't be like, go contact Cosmic Skeptic. Yeah, I don't know. I never want to bring up controversy. Geomicrobiologist now, he's a nerd. That's awesome. That's so awesome. So glad to hear that. We love nerds here. And I never want anything to be controversial here. I want everyone to share their views. I want everyone to be open. This is like the way office hours are. We're here to support everyone. Like Brian's views on like eating meat. He literally ate bacon this weekend. So I just don't want to think Brian's like, no. It's you do you. You do you. You be happy and make the lives of others around you happy. That's what we support. We support positivity here. And there's like a no judgment zone. Because Brian just ate bacon this weekend, that's why. Well, everybody, I'm gonna go get ready to teach and promote the positivity out there. That's what we do. But for now, everyone, what do we say? Gotta get the button ready. We always say, love this. Good luck on the exam, everyone. Thank you so much, Coop, for the positivity. Brian, if I can be honest, I enjoy these conversations, the openness. Yeah, that's what it's all about. You can give your points. I just want to put this out there because I want everyone to know this. And Alexander, you got it right there. Like Alexander, you just phrased it perfectly. It's about openness. That's all it's about right here. Like this is a free space for you to give your view. Like I'm not talking to you. We're talking with each other right now. So, and you're like, well, I don't hear anyone, Brian. Well, they are talking to me right here. I can't imagine my family going vegan. We live by, I know, almond yogurt. Oh, okay. You just hit upon it. Like I just realized this, and I don't know if I could ever go completely vegan. Cheese. And Cosmic Skeptic makes good arguments against that. You go watch his TEDx talk and stuff like that if you want to hear his arguments on it. Like, kind of like, okay, wait, so you're saying you love cheese, but I'm not going to make his arguments, but I'm like, God dang you making these arguments. I love cheese. Come on, man. I love cheese. Come on. If you want, check out his arguments against it or try... Oh, there we go. Thank you, Coop, right there. And this is just... Oh, thank you. This is after class right now. This is not. It's a stats one behind me, but he'll put up the 80s theme. I enjoy this too. It's nice to, he'll put up 80s theme. There we go. Now we're not stats one, we're 80s theme. A real conversation, just talking about stuff. My family put yogurt in just. Yeah, exactly. Like it's like more of a sour yogurt snare. Like, just sounds so good, man. Like it's like falafel and stuff, or like, well, that's Middle Eastern. Man, I'm just thinking about like a gyro with some sort of yogurt on it and stuff. Man, these guys are making me so hungry. Check out does anyone know, last thing, let's give a shout out here to one last place. It's like a plain yogurt, not too sour. I love sour yogurt and stuff, like sour, amazing. Does anyone know the guy's place downtown Knoxville? Got voted the friendliest place, like I think in America. It's not flavored. I think I've had that. I think I've had that before. The guy, what is his place? Give a shout out to him right here. Check it out if you haven't, and support local businesses as best you can with keeping safety guidelines. What is his name of his place? It's really good. I think it's Yasan's Falafel House. Over 1,000 reviews. Yeah, that's it. Man, I miss Knoxville. So good. Yeah, Yasan's. I had him cater my wedding. Exactly what we're talking about right here, man. Dude, I was doing some Pokemon hunting. I went and got falafel, or I think got a gyro from there. That was good. Love, yeah, that place and that guy. He's awesome. I was just thinking about like all the food I miss in Knoxville, and because I was just thinking about like tzatziki sauce, and because this is more like Middle Eastern, I think. Correct? Wrong? Everything right? But yeah, support local businesses. I have driven past there so many times and always meant to eat. Alexander, check it out, man. Be safe, keep guidelines, do all that good stuff, help each other out. Vols help Vols. But with that, check out the food, check it all out. We eat there like 3 times a month. I really need to try this cuisine. I haven't been to Knoxville since. Oh yeah, well, when you come back, check it out. We're glad to have you here. I'm gonna head off. Be teaching in 10 minutes. Well, thank you so much, everybody. Lots of fun. Bye for now, one. Bye. Bye, Stay. Bye, Coop. Bye, Alexander. Bye, everyone.